Calculating the molecular formula is not very different from calculating the empirical formula. If you'll remember, the only difference between the empirical formula and the molecular formula is that the empirical formula is the lowest whole number ratio of elements in the compound, and the molecular formula is the actual formula for the compound. And to calculate that, you need one more piece of information. You have to have the molar mass of the compound. And in this problem, we have all the percentages that we have from empirical formula. Adipic acid is 49.32% carbon, 6.85% hydrogen, and 43.84% oxygen. And the molar mass is 176 grams per mole. And from those two pieces of information, we can get at the molecular formula. So just as we did with empirical formula, we're going to assume that we have 100 grams of compound. That will give us 49.32 grams of carbon, 6.85 grams of hydrogen, and 43.84 grams of oxygen. So those are the masses of those elements, but these formulas are based on mole ratios, so we have to calculate the moles of each of those elements, and we use the molar mass to do that. So for carbon, that 1 mole has got a mass of 12 grams, so that gives us 4.11 moles of carbon. For hydrogen, 1 mole has a mass of 1 gram, so we have 6.85 moles of hydrogen. And for oxygen, 1 mole has a mass of 16 grams, so we have 2.74 moles of oxygen. And to calculate the empirical formula, we now just divide through by the lowest number of moles we have, which is a 2.74. So we divide everything by 2.74. That gives us 1 mole of oxygen. 6.85 divided by 2.74 gives us 2.5 moles of hydrogen. 4.11 divided by 2.74 gives us 1.5 moles of carbon. So we have these fractions that we have to get rid of, the 0.5s, and to do that we're just going to multiply everything by 2. So we multiply everything by 2, now we have 3 moles of carbon, 5 moles of hydrogen, and 2 moles of oxygen. So the empirical formula is equal to C3H5O2. And that empirical formula would give us a molar mass of 73 grams per mole. But the actual compound has got a molar mass of 146 grams per mole. So we take the molar mass that we know, 146 grams per mole, and divide that by the molar mass of the empirical formula that we calculated, 73 grams per mole. And that gives us a ratio of 2, which tells us we need to multiply all of the subscripts in the empirical formula by 2, and when we do that, we get a molecular formula of C6H10O4, right? So there's the molecular formula, and that's one way to calculate it. Starting with the percentages, just as we did with empirical formula, and adding the extra step of using molar mass. Now, there is another way to do that, and instead of assuming that we have 100 grams of compound, we're going to assume that we have 1 mole of a compound. And if we have 1 mole of a compound, that would mean we've got 176 grams of compound. And since we know the percentages of each of the elements in the compound, from that total mass, we can calculate the mass of each element in the compound. So for carbon, we have 176 grams of compound, and its percentage was 49.32. So we multiply that by 0.4932. We convert it to a decimal, and that gives us 72.0 grams of carbon. And we do the same thing for hydrogen, right? we take the total mass of the compound, 176 grams. Its percentage was 6.85%, so we multiply that by 0.0685, and that gives us 10.0 grams of hydrogen. And then for oxygen, we take 176 grams, multiply it by its percentage, 0.4384, and that gives us 64.0 grams of oxygen. So now we have the masses of all of those elements, and what we need is the moles of them. So again, we use the molecular mass. So for carbon, 1 mole has got a mass of 12 grams, so that's 6 moles of carbon. For hydrogen, 1 mole has a mass of 1 gram, so that's 10 moles of hydrogen. And for oxygen, 1 mole has a mass of 16 grams, so that's 4 moles of oxygen. That gives us the molecular formula. So the molecular formula is equal to C6H10O4. 2 different ways to calculate it, but you still arrive at exactly the same correct answer.